Okay, we are doing a review of simplifying rational expressions. Here you can see we have two fractions. The second fraction is being subtracted from the first. And what we should do first is look to see if we can simplify either of these on their own as separate fractions. So I'm going to highlight these just to show you we have a fraction here and a fraction here. Look at them separately first. And what you should notice is our second fraction all has constants and coefficients divisible by 2. That means we can go ahead and divide all of those by 2. That'll leave me with a 2. Dividing this by 2 will leave me with 1. And dividing this by 2 will leave me with a 4. If I look back at my first fraction, there are no common terms between 6x and negative 1, so I cannot simplify anything there. So what I'm going to do is I'm going to scroll this down a little bit and rewrite my fractions. So we have a 6. Let's see if I can use my stylus. There we go. And an x minus 1. And we are subtracting 2x plus 1 over 4. So what I've done is I've simplified my problem first. Now I finish simplifying. I'm not going to do any more canceling until I get to the end of the problem. Because now what we need to do is create common denominators. And if anybody remembers, the easiest way to do that is to multiply each fraction by its opposite denominator. So I'm going to take this 4, and I'm going to multiply my other fraction by 4, both top and bottom. Remember, it needs to be both top and bottom because that's the same as multiplying by 1. If we just did the bottom or just did the top, we would actually change the value of the fraction. It would no longer be the same problem. Notice I've put parentheses around my x minus 1 because we will have to distribute this 4 to both terms. On the other side, I'm going to be multiplying by its opposite denominator, which is x minus 1. So on the top, I need to do x minus 1. And in the denominator, I'm going to do x minus 1. Again, we have to do it to the top and the bottom to make sure that our fraction stays equivalent. All right, so let's go ahead and simplify. If I do 4 times 6, that's going to give me 24. It's a big 2. In the denominator, I'm going to distribute, so 4 times x, that's going to give me 4x. And 4 times negative 1 is going to leave me with negative 4. Again, do not cancel now. If you remove a 4 from all these, you're going to undo your common denominator. On the other side of my fraction, I need to make sure I leave this negative because we will have to do something with that. I'm then going to put my answer in big parentheses. Many of you may remember we need to do FOIL. So I'm going to multiply my first terms together, and that will give me 2x squared. I'm then going to multiply 2x by negative 1. These are our outside terms. That gives me negative 2x. I'm then going to multiply my 1 times x, and then my 1 times negative 1. So I'll end up with plus a single x and minus 1. In the denominator, we are going to have the same denominator we got over here because we're doing the same thing. We're distributing 4 times x and 4 times negative 1. So I should end up with 4x minus 4. And you'll notice now that my denominators are the same, so I can go ahead and combine my numerators. Now since these are the same, that will be the denominator of my answer. So I'm going to say this is equal to my big line. I have 4x in my denominator minus 4. And then I'm going to come up here and do something that we haven't done yet with our negative sign. Remember, when you're subtracting something in parentheses, you actually have to distribute that negative to each piece. So I'm going to change all the signs of everything inside the parentheses over here. My 24 will stay the same, and then I'm going to have negative 2x squared plus 2x minus x and plus 1. So remember that negative, it changes all the signs. What was positive becomes negative, what was negative becomes positive. And the last step for our problem here is to combine like terms. So my negative 2x squared is the only x squared term, so he's going to go out front because, like good mathematicians, we write in standard form. That means our highest exponents come first. And then I have two x terms. So I have 2x minus x. That's going to leave me with a single positive x. And then I have 24 and positive 1. So that will give me 25. My denominator hasn't changed at all. We haven't done anything to it. So it is going to stay as 4x minus 4. The last thing I will do is check, do any of my coefficients share common terms? So if I look at the top, we have a negative 2, a positive 1, and a 25. They don't have any common factors with 4 or 4. We have some x terms, but the 25 and the negative 4 do not have an x, so I cannot cancel anything. That means this is the end of the problem. So you have successfully subtracted two rational expressions. So we went from 6 over x minus 1 minus 4x plus 2 over 8. To recap, we simplified a 2 out of our second fraction. We then created a common denominator by multiplying the left fraction by the right denominator and the right fraction by the left denominator. I multiplied the top to simplify on the left and distributed my 4. On the right side, we did some FOIL. First, outside, inside, last, and we got 2x squared minus 2x plus x minus 1. I then distributed my negative and combined my like terms. So that is a recap of how to subtract rational expressions.